it's lovely to see you and thank you for joining me for today's maths lesson. So you'll know that every maths lesson starts with counting. So please pause me now to practice counting on in ones, twos, threes, fives and tens, and do that in both a forwards and backwards direction, right up to the 12th multiple. I'd also like you to have a go at this. I've pasted this into your home learning for today, and this is a link which will help you to practice your doubles and your halves. In year 2, it is expected that we know up to double 20 and half of 40. And that's a game called dartboard doubles, which will enable you to practice that. Now let's do some table troopers together, and we thank Dave Godfrey for this song which we sing in school. So we are the table troopers, learning as we march along. Table troopers, learning as we march along. 2 times 4 is, 2 times 5 is, 2 times 10 is, 2 times 12 is, 2 times 6 is, 2 times 2 is, and 2 times 1 is. Brilliant. Table troopers, learning as we march along. Table troopers, learning as we march along. 10 times 1 is, 10 times 4 is, 10 times 7 is, 10 times 9 is, and 10 times 10 is. Brilliant. And you could carry on for your 3 times table and your 5 times table also. I'd also like you to have a go with your grown-up, or maybe a brother or a sister, or even you could use some objects to do this. I'd like you to practice your number bonds to 20. You could play tennis, so I could have my tennis racket ready. I would bat you 2, you would bat me 18. I could bat you 17, you would bat me 3. And when you've cracked that, you could do your number bonds to 100, starting at your multiples of 10, for example, 50, 40, 60, or if you're feeling really confident, you could have a go at some other numbers like 99 and 1, or 11 and 89. Just have a go, have fun with numbers, which is what we love to do in our class. Now for today's learning, the learning objective says, how can I make arrays to show multiplication calculations? So we call them calculations or equations, and we have started to look at this word multiplication. We know the symbol for multiplication looks like this, and we know it's also the same as repeated addition. We've got an example there. What I'd like you to have a go at now is having a look at the objects I've got in front of me on this table. So if we look at the abacus first of all, it's showing a multiplication calculation here as an array, as are these plastic rods here, as are these wooden discs here. So an array, another word for an array is an arrangement, and it's a visual way of seeing that multiplication calculation. So the multiplication calculation would be written as this, which means 2 multiplied by 5, or 2 times 5, or 2 5 times. And I've shown that in a visual way, which is this one here. So I've got 2 multiplied by 5. I've got 2 5 times, so 1, 2, 3, 4, 5. And because we know how to count in twos, we can say 2, 4, 6, 8, 10. But it also works the opposite way, and you might say, well, that's actually 5 multiplied by 2. That's 5 2 times, and it still gets that answer of 10. So it doesn't really matter which way you look at your array, whether you look at it this way, where it is 2 multiplied by 5, or you look at it this way, and it becomes 5 multiplied by 2, because the answer is still the same. If we have a look at this calculation, this one says 5 multiplied by 5, and that's what I've got on the abacus here. So I've got 5 times 5 multiplied by 5, and it'll be the same whichever way you look at this calculation. And because we know how to count in fives, we can solve that. 5, 10, 15, 20, 25. And the final one is the discs here, and it depends which way you look at it, but if you look at it this way, it's 3 multiplied by 4. I've got 3 4 times. 1, 2, 3, 4. It's 3 multiplied by 4, and we can count in threes, 3, 6, 9, 12. And similarly, if you want to look at it in this way, it's 4 multiplied by 3, or 4 3 times. 4, 8, and it will still get to that same answer, which is 12. What I'd like you to do today is have a little look at these multiplication calculations or equations and see if you can make them. See if you can make them with objects around your home, maybe cereal, maybe pasta, maybe toys, maybe Lego, anything you've got at home, and see if you can make them as an array. So you'll end up with something I've got here, and I would absolutely love to see a photograph of them. If you've done all of those, so your grown-up can set your challenge and write you some more, or you could do it in the reverse order and make the array first and then write the calculation for it. I'd love to see them, class. Take